Hello everyone, my name is Abhishek and welcome back to my channel. So today we are at day 28 of our complete DevOps course, and in this class I will talk about Docker networking, right? So this concept can be considered as container networking as well, but the reason why I am focusing on Docker is till now whatever we have learned in the entire container architecture or the concept of containers we understood using Docker, and even in the last 4 to 5 classes we have been completely focusing on Docker. So that's why I want to restrict this as well with respect to containers, so that you can go ahead and practice your containers with Docker, the networking and all the other projects. So if you haven't watched the previous videos, I would highly recommend you to go back and watch those videos, because we have been following a particular hierarchy which will help you to understand Docker as well as Kubernetes. Going ahead, we will deal with the concepts in Kubernetes as well. Perfect. Now, firstly, let's try to understand why you need networking in Docker and what is Docker networking. So basically, networking allows containers to communicate with each other and the host system. Now, what is this? Okay, so if we take a basic classic container example, what is the usual scenario? You have a host. So the reason I am talking it as a host, it can be EC2 instance, it can be physical server or anything. So I don't want to go into the details. Let me simply call it as host. On top of this host, let's say you have installed Docker. Okay. So typically what happens is you might have installed multiple containers here. So let's call this as container one and let's call this as container two. So this can be your basic development application, and this container can belongs to your finance or payments related things. Okay, there can be a reason one container has to talk to another container, or there can also be a scenario where one container should be completely isolated from another container. Let's understand two scenarios. Okay, scenario one, let's say this is front end container, and this is, instead of finance container, let's call it as backend container. So obviously, front-end container has to talk to back-end container. So there has to be a common way how this container talks to another. So that means there has to be a networking way of how one container can talk to the IP address of another container. And if you leave this case, by default, any container should definitely talk to your host, right? Because like I always tell you, the containers are basically a very lightweight packages or bundles which do not have complete operating system. If you are taking example of a virtual machine, what happens with a virtual machine? Each virtual machine has its own operating system, right? So a VM is basically operating system plus your application, operating system plus your application. So each of the applications, like application 1 and application 2, are completely isolated from each other. So they have, like, you can attach one subnet to this and you can attach different subnet to this. So what is a subnet? Subnet is basically your networking group. I mean, I don't want to go into the details of subnet now, but basically, let's say you can say 172.16.1.1 here, 1.2 here, and you can say 172.18.3.4. So this network and this network are completely isolated. So by default, you have that flexibility in your virtual machines. Whereas, like I told you, there are two scenarios with respect to your containers. So the scenario one can be one container should talk to another container, because, like, let's say this is a front end container, this is back end container. So obviously they have to talk to each other. So the second scenario is you might want a very good isolation between this both of these containers. Like I told you, you can understand this containers as a payment related container, which has a very secure information about your user details, or it has very secure information like you have stored credit card information or debit card information in the payments related container. Whereas you have another container that is just like a login one. Okay, so anybody who has access to login container should not have access to payment container, right? Because this is a very basic container. Like he can be a development user, he can be admin, he can be tester, he can be anything, but you want a logical isolation between these two containers. So scenario one is both can talk to each other. Scenario two is you want a very good level of isolation. So container networking offers you both of these solutions, and both of them are very, very important. So before I explain you both of them, or before I explain you what are the different types of networkings that are available and what are the different types of networkings that you can create to achieve number one and number two. Okay, so before that I'll explain you the concept of how a container can talk to your host operating system, or how a container can talk to your host. So let us write point 1 and point 2 so that we have a very clear understanding. Point 1 is container 1 talks to container 2. Step 2 is container 1 has isolation with container 2. Now we will also do a very good practical demo at the end of the video so that you understand this entire concept. Okay. Now, how does a container basically talks to your operating system, or how does a container talk to your host? Let's say you have created a container here. Okay. So this is my container. Let's call it C1, which has an application. And this is my host. Anything, host can be anything, right? So EC2 instance or anything. By default, whenever you are creating host, or even if you look at your laptop, there is a network called ETH0. So ETH0 is a special network that is available out of the box. Let's say this network has 192.16.3.4, for example. And here you have a container. Again, ETH0 network is by default created for any resource that you are creating, whether it's a container or a virtual machine or anything. So here, let's say this is 172.17.0.2. Now you can clearly see that there is a networking, or there is a subnet difference. This is 172.17 and this is 192.16. If you try to ping from this to this, what you will see is you will see a networking error. So container cannot ping to your host. So to solve this problem, what Docker has done is, whenever you create a container, so Docker creates a virtual ETH. Okay, so there is a virtual Ethernet which basically is Docker 0. Okay, so you can also try it on your laptop and see. So without this virtual network, a container cannot talk to your host, right? So by default, whenever you are creating a container, this gets created, right? And this is called as bridge networking. Okay, so what is the default networking in Docker? The default network is a bridge networking. The reason why it is called as bridge is because a container has a different subnet and your host has a different subnet. But how a container can talk to your host by default is using a bridge, and this bridge is a virtual Ethernet, right? So it is called as vEth, which is Docker 0. So if you try to delete this network, or if you try to somehow manipulate this network, a container can never talk to your host. What happens if a container can never talk to a host? That's it. Like if a container, like you all of you already know that a container does not have a complete operating system, or a container requires, like for example, a user is trying to access your application within the container, but the container is sitting with inside your host. If user is only able to access your host and not your container, then your application that is sitting inside your container is not reachable, which is, that means there is no point of you using containers, right? So what happens if there is no bridge networking, or what happens if there is no vEth or Docker 0 network out of the box? Whenever you are creating a container, you would land into a problem because the application that you have installed in the container is not reachable from the internet. If the application is not reachable from internet, then users or your clients cannot access your application. That means your application is not reachable, which is, there is no point of installing your applications inside the containers. So that's why, what is the default network that you have, or what is the out of the box network that you get whenever you install containers, is bridge networking. So by default, the Docker network is bridge network. Now, is this the only network? No. So Docker offers you multiple ways. Like if you go back to the example, this is not the only way. Like the this block that you're seeing here, the virtual Ethernet is not the only way how a container can talk to your host. There are different ways, but I'll tell you like the disadvantages of each of them and the advantage of using bridge network. So the other networking option that you have is host networking. That means the containers will directly use the network of your host. So in this case, what Docker does is, whenever you are creating a container, Docker will directly bind your container with the IP address of your host, not the IP address, but the ETH0 of your host. That means, let's say your host has 192.16.3.4 and you create a container, probably you'd get something like 192.16.3.6. So both of them are in the same CIDR block, or both of them are in the same subnet. So by default, when you try to ping from the container to host, it is possible. So anyone who is trying to access the application inside your container can directly talk to the application, because the host networking and the Docker networking is same. So that means whoever access to your host can directly have access to your container as well. But this is a very problematic approach, because you know uh, you want containers to be very very secure. One of the primary reasons to go to containers itself is they are very secure in nature. If they are not secure, you have to make them secure, right? So why containers are secure? And we also talked about, like you remember, we spoke about distroless images, right? We spoke about all of these things to make your container secure. So if you have a complete operating system, or if you have a complete networking that is common to your host, so you will land into the problems. If you have complete operating system, there can be issues with the packages that your operating system have, which have no reason why your application has to use that packages. So that was one of the problem of using complete operating system. Or if the networking is common, someone who has access to your host, okay, by default, because your container as well as your host share the same network, then again they land into the issue, because the this is one of the most insecure way of creating networking in Docker, that is the host networking. And there are other ways as well, like one of the other option that you can do is overlay networking. But this is somewhat complicated, and we will learn very much about the overlay networking when we move to Kubernetes or Docker Swarm. Okay, so overlay network is very popular when you are dealing with this COE, or uh, container orchestration engines, because the overlay networking is very useful when you have multiple hosts. Let's say instead of one single host on which you install Docker, if there are multiple hosts and you want to create a cluster on this multiple hosts, so overlay network will create a network that is common across this multiple hosts. Okay, so I don't want to go into the details of overlay networking and why you should use over. If you are just using Docker, and if you want to just run containers on your Docker, then overlay networking is too much. You don't even have to bother about it. So there are other networking as well, but these three are very popular networkings. Now, if you go back to the problem, so I mean, or if you go back to the example that I just explained you, what did I explain is there is this one host, and on top of this one host, if you install container one, which is called container C1, right? This is each zero of container, this is each zero of host, right? So now there is a virtual ETH that is created, which is called Docker 0, using which you are talking to your host, right? So user can access from your host to through this virtual Ethernet to your container. Let's say there is another container, C2. And if you go back to the example, this is login container and this is finance container. In the previous example, it was front end and this was back end. So definitely one container should talk to the another container. But here, one of the container is just a login container and the other is finance container. So this container has to be completely isolated, or as much secure as possible from this login container. But if you use the default networking option, what happens is there is only one v8 or there is only one Docker 0. So the finance application will also use the same virtual Ethernet, and using the same virtual Ethernet, it will talk to the host. That means both of them are using the same virtual Ethernet, that is Docker 0 or Docker O. So this is the problem. That means there is a common path for the hacker. Okay, so this is the common path for the hacker. Or even if not the hacker, like it can be your internal hacker, or internal any person who wants to mess up with your network. So there is a very common path if you are using the out of the box bridge networking. Okay, so all of the containers, if there are 100 containers, all of these 100 containers can ping, one container can ping to the other container, or one container uh, can talk to the other container using this v8, or one container can talk to the host and the other container can also talk to the host using the same v8, that is Docker 0. So this is the out of the box nature, and this out of the box nature is also not secure. So for some people, this might be okay, right? Because you might say that, oh, okay, I don't have any problem. One container talking to the another container. I don't want any networking isolation between my containers. So this can be step two that I talked about. So there are two cases. One is one container should talk to another container. The case two is one container should not talk to another container. If it is front end and back end containers, they can talk to each other. But if it is login and finance, this application has very secure information like user database or the employee details or anything related to finance of your organization. Whereas this is a basic login application. So there has to be a logical network isolation. How do you achieve this? Okay, so this can be achieved again by using the bridge networking itself. Okay, so like I told you, there are three networkings: bridge, host, overlay. Using host, you can definitely not do it because all of the containers share the same host network. So that's not possible. Overlay network is again very complicated and you don't want to implement. So how do you achieve this with using bridge network? So what Docker does is it will allow you to create your own custom bridge networks. What do I mean by that? So Abhishek, previously you told that there is only one bridge network that is out of the box. Yes, I am right. So out of the box, whenever you are using Docker, there is only one bridge network. But I did not tell you that you cannot create multiple bridge networks or custom bridge networks. So by default, a container will talk to the host using ETH-O, that is vETH, right? So the ETH-O of here and the ETH-O of here are connected using the Docker O network, which is a virtual Ethernet, right? But what a containers or what Docker offers you here is you can create custom bridge networks. That means instead of you going through the same path, if we go back to the same example here, instead of everything going using the same path, what you can do is you can split your network. Okay, where is that slide? Yeah, this one. So here what you can do is the ETH0, this one here, the container one, that is a login container, because it does not have to be secure. It can use the veth, it can use the docker 0 and directly talk to the host. Whereas I'll create a new custom bridge network for my finance, and using this custom bridge network, which I'll call it, if this is docker 0, I'll call this as custom bridge network, for example. And using this custom bridge network, I can talk to this host. So what happens is this chain that I was talking about is broken, or this common path is broken. Now this will directly talk to the host using docker 0, and this will directly talk to the host using the custom bridge network that I created. So this is how you achieve the logical isolation in Docker using the bridge networking itself. Okay, so if I have to explain you one more time so that the things are very clear to you, this is your host, right? And this is the ETH network. Let's call it 172.16.3.4 of the host, right? And this host has, for example, a virtual, sorry, ETH0. This is the ETH0. Now, I created container 1 and I created container 2. I created container 3. This is just login app. This is just logout. But this is payments and finance related things. So this has to be very secure. So for container 1 and container 2, I will not do anything. I'll just create containers as we learned in the previous classes, right? In the previous classes, I just told you just run docker run command and your container gets started. So I'll use the same method here. And what happens is both of them, they will connect to the virtual ETH. From there, they'll connect to the docker 0. I mean, there is again, this is just for your understanding. So there is only one virtual Ethernet network from which it will connect to this host. Whereas payments 3 or the container 3, the finance container, which has to be very, very secure, what I'll do is I'll create a custom bridge network using the docker network command. Okay. And using this, what happens is when I create a new network, for the docker run command, I can simply pass this network as an argument, hyphen hyphen network. Okay, I'll pass this an argument, and what happens is this will connect using this virtual bridge network that you created. Let's call this as virtual bridge. Anything, you can call this as anything, to the host that is ETH0. So container 3 is completely isolated from container 1 and container 2. So this is how the networking in Docker is very useful. So to communicate between one container to the another containers, by default, there is a common network that is called as Docker 0, using which you can talk from one container to the another container, right? Whereas if you want to even segregate, or if you want to even create a networking isolation, you can achieve it by using the virtual bridge networks or the custom bridge networks that you can create. Now let me explain you this practically. Okay, so theory we have learned. Now let's try practically so that everybody who is watching our video can also understand this practically. So let me share my another screen and explain you. So I hope you are watching the screen. Let me increase the font. So I'm using the same repository. If you people don't have this GitHub repository that I'm using, you can clone the GitHub repository. So if I do git remote -v, people who are already watching our videos, they already know that I am Veeramalla is my GitHub repository, and I have GitHub account, and I have all the demos here inside this I am Veeramalla. So Docker 0 to Hero is basically covering all our Docker examples. So in this case, I'll show you a classic example where I have, let's say, a basic Nginx container. Okay, so what I'll do is I'll just use this Docker run. Okay, -d command where I'm running this Nginx in a detached mode. Let's say this is my login container. Okay, so I'm calling this as, okay, instead of container one, let me call this as login, right? So as soon as I do this, what happens? My container is running in the detached mode. Now I can log into this container, right? So I can just say docker exec -it followed by the name of the container, that is login. Let me just say /bin bash. Okay, now I logged into this container. Let me install a few basic things here. Apt update. Let me do update. So once I do the update, I'll install ping command. Okay, by default ping is not available. So let me install ping. I think the command to install ping is apt-get install iputils, I guess. Let's see. Okay. This is not the command. Let's try to understand. Let's try to take some help here. Mm, Ping. Let's see what is the command for this. Okay, it's iputils ping. No worries. Okay. So as I install this, now you'll see that the ping is installed. Ping -v. Perfect. So the ping command is installed. Iputils is the package that offers this ping. So now ping is installed. Now let me run another container. Okay. So I'll use the same command, but this time what I'll do is I'll just change the name to logout. Okay. So as I do this, what happens is one more container gets run. Now I can log into this container docker exec -it again. Or let me first understand the IP address of this container. Okay, so docker ps, I'll see that there are two containers running. One is the logout container and one is the login container, right? This is login container and this is the logout container. So for login container, I have already logged in here. Let me see what is the IP address. So how do I do that? Docker inspect followed by the name of the container. So as I do this, you'll see that the IP address for this is 172.17.0.2. Let's see what is the IP address for logout. So because we are using the default bridge network, both of them should be in the same subnet. So they are in the same subnet, right? 172.17.0.3 and the other one was 172.0.2. Let me log into this container, which I already logged in, sorry. So I'm already in the login container. Let me do ping 172.17.0.3, which is the IP address of the logout container. Let me see if one container can access the another container which are on the same host. They can definitely do that because they are using the default out of the box bridge networking, which allows one container to talk to the another container, right? So we saw that using the inspect as well. So see here, what does it say? The networking that is available on this container is bridge network, because this is a default network, right? So if you want to list out all the networks on this host, what do? You can simply do docker network ls. So as I do this, you will see that, okay, so there is bridge network out of the box, host network, none, and test. Test is one bridge network that I've created. If you want to just delete, you can say Docker network RM test. Okay, so the test network is deleted. So again, if I do Docker network ls, you will see that there are 3 out of the box networks. Perfect. Now I told you how to connect from one container to the another container. Also, I told you how to create a networking isolation from one container to another container. Now, this container, login container, was able to talk to the logout container. But now I want to create a finance container, and this container has to be logically isolated from login container. So for that, what I should do, I need to create a bridge network for this finance container, right? So firstly, the command to do that is Docker network bridge secure network. Let me call this as secure network. Okay, so what was, okay, sorry, Docker network create, instead of create I said bridge. Okay, so by default, if I say Docker network create, the default network custom network that would be created is the bridge network. Okay, so Docker network create secure network. So now if I do Docker network ls, you will see that for any new container that you are creating, either you can attach bridge network out of the box one, either you can attach the host network, or you can also attach the secure network, which is again a bridge network, but it is a custom bridge network that you have created. And the name that we have chosen is secure network. Now, let me try to assign this secure network to the finance container, and let us see if this login container can talk to the finance network or not. And my expectation would be they should not be able to communicate with each other, because I want to keep this container secure. No other container should talk to it because it has very sensitive information. Let's see how to do it. So let us use the same command called docker run -d, and here I will name it as finance. But the only thing that I would do is whenever I'm creating this, I will pass an argument called hyphen network, secure hyphen network. Okay. Sorry, I think the name here, I mean, the syntax here should be is equals to, I guess. Where I am doing wrong. Oh, sorry. Hyphen name is finance, followed by the networking that I wants to pass and the name of the image, right? So this image is created now, or this container is running in the background. Let me do Docker PS. So you'll see login, logout, as well as finance. Let's inspect finance and see what is the networking of it. Docker inspect name of the container. So you will notice that here inside the networks previously, whenever I was showing you for the login container, it says as bridge, but here it is saying as secure network, because we have allocated it a dynamic or the network that we have created. And even if you look at the IP address, it is 172.19. Previously, if we inspect the login container again, so that you can understand the difference parallelly, docker run logout, you will see that here it would be bridge, and here it will not be 172.19, but it would be something else. So let us see if I am right or not. Docker inspect logout. So the network is bridge and the IP address is 172.17. Whereas in this case, the network is 172.19, right? So if you don't, I mean, if you want to see this practically, what you will do, copy this IP address of finance, try to ping it from the login container, and you will see that you will not able to reach the finance container. So this is how you will make your container secure using the concept of networking, right? Is this clear? The concept of networking is easy, right? So the login container, if I go back here, there are 3 containers. Okay, so if I do Docker PS, you have login container, you have logout container, and you have finance container. So login and logout by default are with the bridge network. The out of the box are the default bridge network, so they were able to communicate with each other. Whereas the finance container, right? So it is with the secure network that we have created, so it is completely isolated. Now let me also show you the other case where I want to create a container, but this time I want to create it with the host network. So let's call this as login is done, logout is done. Let's call this as demo. Okay, host demo. So the name of the container is host demo. Docker run -d hyphen hyphen name host demo. To attach it with the network, what we need to do, we have to pass hyphen hyphen network is equals to host. Okay, so now I'll run a container with the host network and let's see what happens. So what would be the IP address of this host network or the container host demo? Any guesses? Put me the timestamp in the comment section and answer your question. Let's see how many people understood this concept. So if you have got this answer correct, what you will see is the container host demo will have IP address completely different from other containers that we have created till now, the login, logout, and finance, because the networking is the host networking. Let us do docker ps and you will see that there is a container called host demo. If I inspect this using docker inspect host demo, you will see that the networking is host and the IP address. You see what is the IP address? There is no custom IP address here because it is binded with the host networking itself. So Docker did not create any virtual network in this case because directly you are able to access this container using the host itself, the host IP address itself. Got it? Is the concept clear? Perfect. So now I hope everybody is understanding what we discussed with the networking. If you have any questions till the point that we have discussed, because in tomorrow's class what I'll do is I'll talk about few docker interview questions because everybody have been asking about it. If not, my actual plan was to start with Kubernetes, where I wanted to end docker with networking and start Kubernetes so that people will correlate, like you will understand the problems with the docker here. In this case I have to create my custom networks every time, whenever I want to keep it secure, or even to access these applications inside the container from external world, you have to do some kind of things, right? You have to do some port mappings, you have to do all of these things. So how Kubernetes as a platform or how Kubernetes as a container orchestration solution solves all of these problems, or what happens if a container goes down, what happens if a container you want to scale up because of some load. So Kubernetes has answers to all of these questions: auto healing, auto scaling, all of the classic problems like networking in the container. So my initial intention was end with Docker network, the concept of Docker, and start with Kubernetes. But now, because people are asking about interview questions as well, I will introduce one more class for Docker interview questions. Perfect. So I hope you like the video. If you like the video, click on the like button. If you have any feedback or questions to me, put that in the comment section. And finally, please don't forget to share this video with your friends as well as your colleagues, because it is very important for everyone who are trying to pursue their DevOps career, understand from zero to hero. Like we have already covered 28 classes, so it will be very helpful for them. Thank you so much. I'll see you in the next video. Take care, everyone. Bye.